So today we're going to talk about inheritance. Before we dive into code, I want to say that the purpose of making classes inherit classes should be to write less code. So if you're writing your program and you notice that you're writing a lot of classes that have similarities, then you might want to think about inheritance. So what is inheritance already? Actually, can someone take a stab at it?
It's when one class inherits properties and methods from another class.
Yes.
And simplifies the addition of that next class.
Yes, those are both correct. So inheritance is just a relationship between two classes. One of them will be a parent class or a superclass, and then the other will be a child class or a subclass. So you might see those terms used interchangeably. So parent and child classes and superclass and subclass. So specifically, inheritance will help us model the relationships where one class is a subtype of another class, like we were mentioning yesterday. A dog is a type of animal. So animal would be the superclass, dog would be the subclass. So all dogs are animals, but not all animals are dogs. So let's see this dog example. So this is just the dog class that we've been seeing for the last few days. We added an eat method, and here we're instantiating a dog called Spot, and then we're saying spot.eat steak. And if we run this, I think I'm in the right directory. Okay, Spot eats a steak. Pretty straightforward. So let's say we have a cat class here. So we have a dog, we also have a cat, and this cat also eats, but instead of bark, we have meow, because that's what sound the cat makes. And so we instantiate a cat. We will also get Garfield eats a tuna. So in here, we notice that they both have the attribute name. And then we also notice that we have a similar method, so eat. And we also have a similar type of method for like whatever sound that animal makes. So in this case, we would definitely we definitely should use inheritance, because it would just make our code less redundant. So we have a lot of repeated code here. So let's create that. Class animal. And in this class, I'm going to define an init method. Oh, that was cool. Where self.name equals name, and I need to send that in. So this was just created by my editor. I think when you add this might be the expected return, if I'm not mistaken. So you don't really need this, but I think it helps with writing your programs, just to make sure that it will throw an error if you say that you want to return a list and you're not returning anything. But I need to look more into that. I could be wrong. Okay, so we have our instance variable, or our instance attribute, and then we're going to define, just copy eat, because it is going to be the same for both animals. So now since I have it in the animal class, I can delete it from dog and I can delete it from cat. So we already have one method that took away two. And then instead of bark and meow, we can just say speak. So we can call, oops. We can name this speak. Send in self. And print. Okay. I'm an animal. Okay. So let's comment these ones out first. Okay. So how do we allow our classes to be inheriting from, to inherit from animal? The way you do this is you put parentheses here and you just put the class that's it's going to inherit from. So dog, I added that it inherits from animal, and I'm going to do the same with cat. Animal. And so both dog and cat are subclasses of the superclass animal. And so now if we create this dog and this cat, we should be able to still run these. Let's see what this does. And it works. So what happens when you add this inheritance? It pretty much allows you to use the methods and the attributes that are in here. Actually, I forgot to remove our init because here I need pass just so I'm not getting my squigglies. Okay, so dog inherits from animal. That means that dog will now have access to all of these built in. So when I create a new instance of dog, it's actually creating a new instance of animal as well. So now if I run this, I'm still getting the same results because when I instantiated dog, it went to the init function of animal and initialized a name. So let me print out the name so we can check. Print spot.name. There we go. So it prints out the name. And you also have access to the methods. That's why we were able to say spot.eat and it still worked. Yeah, Jim.
So without changing any code, it strikes me then you would be able to go above animal or maybe you could even almost convert animal to carnivore, and above that you could add mammal.
Yes. Yeah, you can have different classes.
But you wouldn't change anything below, right? I mean, if you would just go above right now and create vertebrate or whatever.
Like mammal.
There you go, yeah.
Okay.
And you go, okay.
Yeah, you can. So if I say class.
And nothing else changes below. Nothing
will change, no.
Cool.
So if mammal has specific, so yeah, one second, let me just do this. Let's say to initialize a mammal, I don't really need anything. So I'm just gonna say pass for now. Or mammal equals true. So now if I just added this and I run this, let me try accessing spot.mammal. Spot.mammal. I guess the more correct way would be is mammal, so that way we're asking a question because it's a true or false. But it's out. Does not have this. Okay. Oh, okay. So actually, we will talk about this towards the later, like having multiple inheritance, but I'll keep this up here and we'll talk about why this didn't work and what needs to happen.
Was it the brackets because you called it and it was just an attribute?
No, because it is an attribute, but oh, you mean this, the parentheses, yeah. Okay, that's possible. No, it shouldn't, yeah. So we need to do an extra step to do that, and I will show you guys. Actually, hold on, I could be wrong. No. Yep, I know what happened and what needs to be fixed. So I'll address that towards the later part.
Part of the direction of my question was, if in the future your code wants to accommodate, I mean, imagine that animal is a subdivision of a company or a city, and then you want to add state above that and add country above that. I was just wondering how you would extend this. So that was the thrust of my question.
Yeah,
so
let's.
If you were to strike the change you just made on lines 21, does all the code still work?
On line 21 here.
What was the last thing you added that you were having some troubles with? That one, okay.
Oh,
So
yeah, so let's address this after I get through this part, because
okay.
Yeah, what I'm gonna address after this part, will probably answer your question. Okay, so let me kind of reiterate what happened here. So I'm gonna just clean my code up a little bit so it's more visible. So we had a class dog and a class cat that did a lot of the same things. So we abstracted that functionality into a higher class animal that holds a name, has a function to eat, and has a function to speak. So now when we instantiate a dog, it'll automatically call the init function of animal. So in this case, let's say dog doesn't have any other attributes, so we're completely fine with just having a name. But the one thing that dog has something specialized is the bark. So same with cat, we would have meow. So what we can do is actually override the speak function. So similar to how we had our string, our dunder string method, where if we have it in somewhere, if we have it in a class somewhere, it will override how we want to print that thing out. This will let us overwrite our speak function. So if I say define speak, oops, self. So in here, I can just print bark. And what this will do is in here, so I'm gonna delete this part.
Our program is a joint in-person.
Someone has a
program, but we treat it as
hot mic. Okay.
yes. Okay, it's Adam.
Oh. All right, where was I? Okay, so I'm just gonna, I don't really need these print statements here. So we're able to access the name, we're able to have the animal eat, but now if we want spot to speak, So we can say spot.speak. And what do we expect to happen here? If we're saying that we're overwriting the speak function.
It'll say bark, bark.
Yep. Oops, that was not what I wanted to click on. There we go. So we were able to overwrite. So here with Garfield, if I say Garfield.speak, it will still say I'm an animal. Sorry, let me just close this. Probably chose something. But yeah, so because we didn't overwrite anything, when I say cat.speak, it'll take the speak method from animal. So I just need to do the same thing I did here. And just say meow. I don't know how. I guess it doesn't matter because cats don't really have letters, so they won't be offended. So now instead of I'm an animal, it should say meow. There we go. So any questions about this?
Do you even need the speak method in animal to get that working like that, to override it? Or is that just kind of like a good practice to put that in there, knowing you're gonna put it with dog or cat and change it later?
So in general, all animals have the ability to speak. So if you want it to be like part of an animal, they can speak. And these functions are doing the same thing, but maybe you want your what it says to be different. I could also have whatever phrase they say be sent in. But yeah, generally, this is one of those like design questions, but I would say you should put it in animal if you expect all of the animals to speak. And even if you have to override it per animal, that is okay. Because maybe you don't want to override it and it just says I'm an animal because you don't know what sound it makes. Any other questions? Okay, so okay. So sometimes you're gonna have a child class that uses most of the functionality of a method, but needs to add some more to it. So let's say a dog, I think Jim might have asked a question similar to this, like if dog has a specific attribute that only the dog has, how do we accommodate for that? So for this, for animal, we're going to define an init function. So we are overriding the init function here. So init. So for this one, I'm going to take name because name has to be passed into the animal one, and is service animal, let's say, because dogs can be service animals, but cats cannot be. I think it's not it. But anyways, so we have this keyword called super, or a method, sorry. So what this method does is it allows us to access an instance of the parent class so we can actually call a method from it. So if I wanted to just add a service animal in dog, but I still want to take whatever was in the init method, I would say super dot underscore underscore init. So this is going to give me the init function of animal. And I will send in the name because that is all it's taking here. And then I can add whatever I want here. So I can say self dot is service animal. And I can say it's service animal because I'm sending it into and through the initializer. So let's see what this does. So dog, I need to add a true or false. So let's say false for this one. And I'll just print out. Let's print out the name of Spot. Actually, the name is already in here. And then we'll print out the service animal. Okay. Oops. Okay, so we get Spot. That means that our init function was called. We were able to successfully add a name. And then speak still works, and then is a service animal, it said false because that's what we inputted. Questions?
Why do you need to put the name on that on line 17? Because if it's inheriting or accessing that method from the animal class, doesn't it already take in name?
Yeah, so we're sending it in because we're overwriting this. So okay, let me step back a little bit. Before overwriting the init method, it was just calling this method. It was calling this init and it was only taking name. But here we wanted to define another init method that had the ability to take in the data of whether this is a service animal or not. So we need to call the initial init method that was going to be called regardless. And then we're sending it, we're kind of acting as a middleman between this class, between the animal class and between the dog class. So the dog class is adding the functionality of being able to add is service animal. And so we have to still call the animal init because it has like preset things that all animals need, but we wanted to just add a little bit of extra stuff.
Okay, so if I guess if line 6 was like self, name, age, breed, on line 17, you would have to put name, age, breed.
Correct.
Okay.
Correct. Yeah. Yeah, Lewis.
Can you explain what is super doing here again? Like how does it work?
So let me show you what it does. It gives you an instance of the parent class. So parent instance equals super. And then we are able to say parent instance dot init. And then we can send in name. So this one line is basically doing this. It's super returns an instance of the animal class. And then it's allowing us to access the methods in the animal class. So if I print type of parent instance. So its class is a superclass, but it's it pretty much just it gives us the animal, it gives us access to the animal methods and attributes. So, and the reason why we have to have an instance is because if we did, I mean, okay, no, I'm gonna stop there. So this is what it's doing.
So I thought you were taking all those classes by putting animal in the class dog in line 15.
Yes, but since we are overriding init, it won't go to this init because it's gonna go to this one. So when we define a new dog, it's not going to go to the animal init function anymore. It's going to go to our dog init function now.
Okay.
Does that make sense?
Yeah. So you're overriding the first init and making your own init.
Exactly. And
Okay,
because I don't want to deal with like I think Jim mentioned, like if there was color, breed, all of that extra information, I don't want to have to deal with actually defining them over again, because this init function is already there. It works and it does what I need it to do, but I just need a little bit extra stuff. So that way I can just access that init function, call it with whatever variables it needs, and then I can add the stuff that I want as
Is
well.
everything reinitialized when you move down into the dog scope? I think it would be called scope. So what if you identify things in the animal class, like as animal, well, 4 legs.
Mhm.
And then you've got and you were to that might not be the best example, but what if you define something in animal
Mhm.
that you don't describe in dog, and you add your init function? Does the init function in dog only modify the things that it's trying to redescribe in animal? What if there were new
So the stuff,
things in the init section in
Mhm.
animal
Mhm.
and 1 or 2 things in dog?
you can't have that. So because dog is a subclass of animal, you have to have minimum the things that animal takes. And then you can add extra, but you can't have less because dog is a type of animal. So if there's an attribute that you see could be added to animal, but not to a dog, it shouldn't be an animal because it should encompass pretty much
I
like
think I understand
the
that,
basis.
but what if there were dozens of things in animal and 1 or 2 in dog that overwrite 1 or 2 in animal?
Okay, I think I know what you're saying now. Like if it was I guess like the legs example. So if I said self dot legs equals legs, but then okay, so let's just say we're not actually pulling it in, we're predefining it to 2 for some reason, and then we're adding a legs parameter here, we're adding 4, let's say, because the dog has 4 legs, and you're saying, can I overwrite it here, right? Self dot legs equals legs. Like, will this work? Is that what you're asking?
Yes, I think so. So imagine we describe an animal as lungs, vertebrae, and brain. They all have those things. We don't need to redefine those things when we talk about dogs. All I want to say about dogs is they have canine teeth.
Mhm. So
So
that
you
would
got-
only live in dogs.
Canine teeth only lives in dogs, but dogs still were described as having lungs and vertebrae and brains, but we
Mhm.
don't need to re-describe those in dog, do we?
No,
In the
you would,
init?
so you would have to pull them in. You would have to take them in. So everything in, so all the parameters that are in your animal init, you have to at least have those in your dog init. So you can't take, so I can't say that I'm deciding to define a dog, but I'm not going to take in a name, because your animal init function takes in a name. So you have to have a name.
Can you think of it like a pyramid where you can't build a pyramid upside down, but you can build it the right way and it gets bigger as it goes along?
You can
Yes.
put smaller pyramids inside of a bigger pyramid.
I don't think I'm catching on to the pyramid, the pyramid example. Okay, let's,
That's
Yeah.
okay. I think I get it. We're good.
okay, cool. Who else has their hand up? Thomas?
I was just curious with the super, if the parent class has class attributes, are we able to access those using super, not just their methods?
Let's see. Yeah, you can, oh, you're saying the attributes, right? Yeah, you can. So here I'm able to access legs, name, speak, and eat. So if I said name, I don't think it's going to print anything because we hadn't assigned it to anything yet.
I guess what I was thinking is
Oh,
like,
okay, so never mind. Maybe afterwards. So yeah, you cannot. You can't access the attributes.
of your parent class.
Yeah, so what super does, it's not actually making an instance, it's a temp instance. So it's not gonna have everything that, like, we're not instantiating it, but we are taking the ability of calling the init function from it.
So is there a way then, so like we had before in the dog example where we had a list of all the dogs in the pet store, could we access a class attribute from a child class?
So yes, so when we have, so let me say animals equals an empty array. So once we initialize it, and once we initialize a type of dog, because this was part of animals, hence it is part of dogs. So we should be able to access it. Animals. So that was my my list up here. And it should be yeah, it's an empty list. So you are able to access it because everything in animal becomes inherently part of dog because it inherits from it. It's just adding specific functionality to, like with the speak, we wanted to change how the animal speaks. And if we wanted to add extra stuff in a function, we can still call the old function as well.
Okay, thank you.
Let me test it out with here actually. So if I did super dot speak, we might be able to print this out and then this. Yeah, so with spot, it says I'm an animal because we called the speak function from the parent and then it said bark bark. Yeah, Chris.
You might have been hitting on it. So essentially, regarding the two methods that are passed from animal that have the same name in dog. So for example, like eat and speak, if I wanted to call the parent instance of that method, the function like eat or speak,
Mhm.
do I have to pass that to the subclass and reassign a variable? So for example, if I want to say, Fido's a dog, and then I want to do Fido speak, but instead of him saying, bark, bark, I wanted to say I'm an animal. Would I have to call, the super like parent underscore temp instance, dot speak equals a variable, and then, like new speak or something, and then call it that way?
No, so you can't have, if both dogs are of type dog, you have to define what speak means for the entire class. That's pretty much what you're doing. So any dog that I create, so even if I create another dog here, and then true, and how many likes? If I say speak, it's going to print out whatever I have defined in this speak function.
Right. So I was wondering, like in the initial, if you had, so for example, you've assigned parent temp instance on line, 19 or so to super. If you wrote like a new variable within the dog class, something like new underscore speak equals, parent temp instance dot speak, to access the parent function, would you have access to animals method in the dog class? Does that make sense?
Yeah, so the way I did here, super.speak, it will call it. So you can't modify it, but you can call it.
So so when you're calling it there,
so like I did here earlier, when I ran it, it said first, I'm an animal, because it called the animal speak function, right? Because I called super.speak. And then it printed out bark, bark.
I guess the only nuance would be like removing dot speak out of that function, because I understand how it's calling it again, but I wanted the dog to just say I'm an animal, not bark.
Oh, then you wouldn't do any of this at all. So right now, if I do this, this is redefining it. So it will pretty much, it goes into, when you say spot.speak, it goes into the dog class, it looks for speak.
Understood. I'm just saying, like, I want access to both. I want to be able to call the animal speak and call the dog speak separately and independently.
You can,
as an example, Spot should say bark bark, but Fido should say I'm an animal.
I
Yes.
understand. Okay.
Thanks, Sig.
I don't know if that is possible. Remind me of this question. I will do some research. And we'll see after class. Yeah.
Could you have the parent class accept a like a string property in their speak method, and then whenever you call it in the child class, you just pass in whatever you want?
Yeah, definitely. That's yeah. That's possible. Gabo?
They kind of touched on my question a little. Just wanted to confirm. So you would only, if you don't want, like, let's say a dog is definitely an animal and you need all those attributes, but you don't actually, or you want all those methods, but you don't actually want what they currently do in the animal class, you wouldn't call super at all.
Yes,
because
you would
just
redefine
you want to redefine what all of them do, because it's a completely different, it's still an animal, but it behaves completely differently, so you got to redefine everything.
Yes.
And then you would, if you just want to change two things from the animal class, you would do super, So you can still have all that other stuff and then just change exactly what's going to be for bark or for dog. I'm sorry.
Yeah, yeah. So if you don't like any of what's in here, or even if you don't like one of the things inside this method, you do not want to call super, you just want to redefine it entirely. Yeah.
And in thinking of, I think it was Chris's question who just spoke before me. Sorry for reading the wrong name, but you could, if you wanted the original bark or the original sound speak, the original speak from animal, but you also wanted a new one, you could, since it's a new subclass, you can create anything that's not in the first one.
Yes, you can.
So you could just create a method called something else that will make it bark, and call that when you want it to bark, and then call the original when you want it to say I'm an animal.
Exactly. So you can have like here I named it alternate speak, and you can still have access to speak. So if I say speak here and then I print out alternate speak. So we're gonna get both. So we got I'm an animal for speak, and then we got the bark for the alternate method that I created. So yeah, you can redefine multiple ones to be able to access it, but you won't be able to access it with the same exact name. Unless you have like a parameter in here, and then you're overriding speak with a parameter saying like, do you want the original one or something like that? And then if original, then you can call super. If not, then you can do the bark. So that is a possibility.
I was literally just thinking about using the if statement there to determine if it was Spot or Fido. So
yeah,
that works.
Yeah. Yazid.
I think Thomas or someone asked that question, and I want you to go back on your answer. Normally with super, right? We should be able to access the method and the attribute of the parent class.
So
when you did the test, we couldn't access the list that you created, and that should work normally.
So we're able to access the methods in the class when we create an instance of it. We are not able to access it through the super, because it creates a temporary instance that allows us just to call functions, but it doesn't allow us to.
So if I do super parentheses dot, I call the name of the list in the parent classes, and I append something, it won't work.
So super dot animals, right?
Yes, and I append let's say a number to that list.
Sorry, let me just remove this. Did you say up here? Like
yes, up there.
Yeah. So let me try this. Yeah, so we are able to access, okay, now it's working. So we're able to access class attributes, but I do think that if we said super dot name, it might have been defined actually after the init. So we'll see. Yeah, never mind. So super dot name is an instance attribute. So when we create an instance, that's when it's actually created. We don't have access to it by a generic call to animal. So this is like saying, oops, animal dot name. This is also like saying animal dot init. I do think with init, hold on. Yeah, so with init, we have to actually send in itself, because that is how this is defined literally, but if we use the keyword self, or sorry, super, we don't have to send in self. We are just accessing it as like a regular type function. So if I did animal and I have to send in self and name, this is just causing an error. Hold on. So this one works. So yeah, that was gonna be like part of our next section. But saying super init is pretty much saying animal.init, but you don't have to worry about knowing which is your superclass. This kind of fills it in for you. It already deals with the self attribute, and you can just send in name here. Does that make sense?
Yeah, so that's the same thing I'm saying. Like, for instance, on line 22, right? If we do super and then we call the list animal, we should be able to add something to it from there too.
Yeah, let's try that. So animals.append, and we can just say self. And then yeah, it's good. Something will change here because I'm printing out the list down here. There we go. So it adds the dog object.
Okay.
Yeah. So because it's a class instance, we can access it. But if it was, like we saw earlier, if it's name or legs, we can't because it's an instance attribute. I meant class attribute. Yeah. Good questions. Other questions?
So super is just a shorthand then for all of that, right?
Yeah. Super makes it easier to deal with this call. Like I said, you don't have to actually deal with the self or know the name of your superclass. So it just kind of takes care of all of that, and you're able to just call init here. Any other questions? I'll leave that there. Okay.